All right, so this video is going to be on writing equations. In the Math 108, they call it linear equations in two variables. Basically, you're just looking at equations of lines and writing equations of lines. So there's lots of formulas for this. So let's look at, so this is 3 for my one book, but either way. So let's look at our different, I'm going to see if this will come up. I was like, ooh. Maybe. So let's look at our different formulas that we have. So the way that I like to teach writing an equation of a line, oh yeah, that's going to come up good. So I'll discuss these. So the way that I like to teach it is using point slope. And the reason why is because point slope people don't mess up as much. So let's look through all the names of our linear equations, and you can always pause the video and write these down. This one we've looked at a couple times, slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. Maybe that isn't focusing super well. And then we have point slope form. So point slope form is this one here. And I like to think of it as point slope formula. We use point slope to find the equation of the line in the slope intercept form. So again, you use point slope to find the equation of the line. And it goes y minus y1 equals m times x minus x1. M is the slope that you put into the formula, and the ones that are represented by the point that's on your line. So you have to have a point that's on the line and the slope in order to find the formula of the equation or the equation of the line. Standard form, you really basically just get the slope off of standard form. It's not something you use regularly. We've already discussed horizontal and vertical. Y equals is horizontal, x equals is vertical. And if the y's are all the same, then it's a horizontal line. If the x's are all the same, it's a vertical line. All right, so that's kind of the formula that we're going to use. So let me give you some examples of what you're going to see. So the first equation, or like you're going to get bits of information and then you have to write the equation. So what if I was given m is equal to negative 3/4 and I was given the point 0, negative 4? What are they giving you? They're giving you m, which is your slope, right? And then they're giving you a point 0, negative 4. But what is 0, negative 4? Is your y-intercept. So when x is 0, that's your y-intercept. So it gave you the y-intercept. So I would think of this formula. It gave me m and b. So I could put those in and have my equation of my line. So y equals negative 3/4 x minus 4, minus the 4 from the b, right? And there's my equation of my line. So you could be given slope and y-intercept, and all you do is plug them in. And then you could start to be given less and less information. So this one should be fairly easy. All you do is plug them in. What if I'm told, okay, slope is 1/3, and it goes through the point. Well, that's all right. It's got fractions. We'll deal. And it goes through the point 2, 3. All right, so what if I have that information? So now I have the slope and I have a point, but I need the equation of the line. So I will use point slope to find the equation of the line. So I know y minus y1 equals m times x minus x1. So from here, plug in your point xy here and your slope here so that I'd have y minus the y is 3 equals m of 1/3 times x minus x, which is 2. All I did was plug in those three numbers, slope, x, y. Be careful of your minuses that come from your formula. This is the equation of the line. You could be done here. It depends on if, it depends on what they ask for. If they ask for the answer to be in slope-intercept form, which is super common, then you have to simplify. If they don't, you're done. You're done. That's the equation of the line. It has a y, it has an x, it has numbers that relate them. But let's simplify it. So I would then times the 1/3 through the parenthesis here. So I have y minus 3 still. And I'd have 1/3 x minus, think of this as 2 over 1. 2 times 1 is 2. 3 times 1 is 3. So I have 2/3. And then I got to add the 3 over, and I have it in the form y equals. So when I add the 3, it has to be added to the number, right? You can't add it to an x. So that would leave me y equals 1/3 x. Now you have to think about this. 2/3 negative plus 3. So 3 over 1, you could get a common denominator. A lot of you could say, well, 3 minus 2/3 is 2 1/3, but maybe you can't. So then let's get a common denominator times the second one by 3, and I'd have negative 2/3 plus 9/3. Now I have the common denominator. Negative 2 plus 9 is 7/3. And then how many times does 3 go into 7? It goes in there 2 1/3. So you could have got 2 1/3 or 7/3 depending on how you did that. So make sure you get a common denominator if you need to. Here's our answer. There's the equation of the line that related that slope and that point together. Okay, so what if I'm given even less information? So what if I'm just told that I have the points 2, 5, and 1, 6? So what if I'm just told, all right, what's the equation of the line that goes through these 2 points? You will see this if you have to go up through statistics. You'll see this over and over and over. So it's very important you can do this, because you can take data from like last year and predict this year. So it's lots in business as well. But anyway, so I have 2 points. How do I find the equation of the line? Well, I got to start with the slope first. So slope first. So I'm going to go y minus y. So 5 minus 6. 5 minus 6 over x minus x, 2 minus 1. So 5 minus 6 is negative 1. 2 minus 1 is 1. So I got, I'm looking at my answer here that doesn't match. I got negative 1 for my slope. Okay, so then there's my slope of my line. Once I have my slope, I have 2 points. I can then use point slope. Again, I think of it as point slope formula to come up with the equation of the line. So then I'm going to have our y minus y1 equals m times x minus x1. Let's plug in what we know. Doesn't matter what point you use. You have 2. You only need 1. So I like to use the one with the most positives, less ugliness, right? And they're both pretty. So let's just use 1, 6. So I'm going to plug in the 6, minus 6 equals m, negative 1 times x minus the 1. So distribute. If you needed it in point slope, right, we'll keep going or slope intercept. So distribute here, and I'm going to get negative x. Negative 1 times negative 1 is positive 1. So y minus 6. Then I can add the 6 over, to move over to this side over here. So add your 6 over, and you'd get y equals negative x plus 7. Okay, this is in slope-intercept form. What if you wanted it in standard form? Let's go even further. So if it didn't say any form, you could be done here, right? This is all different ways to write the same thing. So here's the equation of the line. Here's the equation of the line. What if I wanted it in standard form? Then what I'm going to do is go one step further, and I need the x to be in front. So I'm going to add that x over so that it becomes x plus y equals 7. And I'm actually done. That's standard form for this one. Now this one was easier for standard form, but you need x, y number. They're very picky. You cannot have a negative x and you cannot have a fraction. So you have to know how to times and get rid of those. So let me maybe show one of those. So I'm just going to write an ugly one. So let's say I solved just trying to think of, oh, here, I could do that one. This is pretty basic. 1/3 x, let's do negative 1/3 x plus y equals -2. So let's say I solved and I got this. All right. This was my standard form. It's actually not considered standard form because it has a fraction. What can I do to get rid of that fraction? And it can't be negative. So what I can do is I can times it by the denominator. All right. So you don't want fractions for A and B. I don't care what C is, so that's okay too. But let's times it by the entire thing by -3. That will then get rid of the negative, because I times by negative, it gets rid of it, and it'll get rid of my denominator here. So times -3 by -1/3, I'm going to get +1, or 1x. -3 times y is -3. Oh, that was loud. -3 times -2 would then give us a +6. So that equation of the line is the same equation, although it's way prettier to look at. So either way that you write the equation, whether it's slope, intercept, standard form, it doesn't matter. They're all just different ways to write that equation. Let me plug this in before it dies. Okay, so that one's a little bit harder one in standard form. Now let's look at some that relate parallel and, well, I'm going to do this one first. So what if I have these 2 points? What do you notice about those 2 points before I go into finding my slope, finding my equation of my line? You should notice the x's are the same, so they're both 2. My formula is just x equals 2, or my equation, or my function, or whatever you want to call it. That's it. Done. If the y's would have been the same, if those y's are the same, then the formula is just y equals that number. This is a vertical and horizontal line, so don't make those ones hard. Look and check. Are the x's the same? Oh, good, I'm done. X equals 2, I'm done. That's it. And so don't make those ones harder than they are. But let's look at one last problem. What if I say that I go through the point 7, 2, and that's a comma, and I'm parallel to 3x minus y equals 8. Right? What if I say this and I say, well, if I go through this point and I'm parallel to this, what is, oops, you can't quite see that all. I'm going to have to take, there we go. So you can't see the question number 7. That's okay. So how would I find the equation of the line with this bit of information? So you can notice I'm getting less and less information, or harder information. Well, we know it goes through this point, so we have a point. And we know it's parallel to this, but we don't have the slope. We know parallel lines have the same slope, right? So my new equation has to have the same slope as this one. So what you do is you find the slope from the equation they gave you. Remember, in standard form, it's -3 or negative a over b. So -3 over -1 or 3. So my slope was 3, and I know it goes through this point here. So then I can use point slope, so y minus y1 equals the m times x minus x1. Again, it's like a formula. So I'd go y minus y1 is 2, xy equals m of 3, x minus x1 is 7, and then I could be done, but what if it asks for it in slope-intercept form or standard form? Let's just show all of the forms. So then I would times the 3 through here. So I get 3x minus 7 times 3 is 21. Okay, then I add the 2 over. Add the 2. and y equals 3x minus 19. So this is slope-intercept. And then if I want it in standard form, I have to move this x over here. And again, you could be done here. This is an answer. This is an answer up here too. It depends on the level of math you're in and what they expect from you. Typically you're done here. If I want it in standard form, I got to subtract that 3x over so that it goes negative 3x plus y equals negative 19. But I said you can't have that negative there. How can I change that sign? I times it all by -1 or change all the signs. So my final answer in standard form would be 3x minus y equals positive 19. I changed. This would be standard form. If you would have been asked perpendicular, you would have got the slope, flipped it over, changed the sign. So don't make parallel or perpendicular hard. If this one would have been perpendicular, my slope is 3, I would have used -1/3 for my equation, for my slope. So there we go. There is a short video on how to write an equation of a line or an equation of a function. No matter which word we use, it's still the same idea.